What does it mean when something frozen starts to breathe? Not a metaphor, not a poetic exaggeration. A literal outgassing, the slow, rhythmic exhale of vapor from a world that should be asleep. That's what astronomers are witnessing right now. An object drifting through the darkness, so far from the sun that light feels like an afterthought, and yet it's alive with activity. Its name is 3I Atlas, or as the media now calls it, 3I Atlas. The third interstellar visitor ever recorded. A cosmic refugee from another star system, and it's doing something no comet, not even Oumuamua, has ever done before. Picture this. You're more than 3.5 times farther from the sun than Earth is. Out here, the warmth that powers our world is diluted to almost nothing. The solar wind drifts thin and weak. Ice stays locked, ancient and unmoving, for billions of years. Everything sleeps. Then, suddenly, one of these icy wanderers starts pouring out water, not trickling, not leaking, but erupting, ejecting 40 kilograms of water every second into the void. That's not supposed to happen. Not here, not this far out. At 3.5 astronomical units from the sun, even our most active comets remain silent, inert, waiting to awaken until they're much closer around the orbit of Mars or even Earth. But 3I Atlas didn't get the memo. Instead, it's acting as if it's sunbathing in Mercury's orbit. Water vapor, hydroxyl signatures, cyanide trails, all exploding from a surface that should be frozen harder than steel. Astronomers are calling it a comet that breathes where it shouldn't. And they're right, because technically, this thing shouldn't even be awake. The discovery came from the SWIFT space telescope, a NASA mission originally built to track gamma-ray bursts. Not comets, not interstellar debris. But SWIFT's ultraviolet sensors picked up something strange in early 2025, a faint but unmistakable halo of hydroxyl molecules around a distant object in the outer solar system. Now here's the trick. Hydroxyl, or OH, doesn't just hang out in space. It's what's left when sunlight rips apart water molecules. You don't see OH unless there's water nearby being destroyed by radiation. And SWIFT didn't just see a little, it saw a lot. Enough to suggest that 3I Atlas was venting 1.35 times 10 to the power of 27 molecules of water per second, an outflow rate that would embarrass most solar system comets when they're 10 times closer to the Sunday. So naturally, astronomers had questions. Why is it outgassing this far from the sun? Where is the energy coming from? What's driving this activity? Because the sun's heat isn't enough. That's been calculated, modelled, double-checked. Even if every photon hitting its surface were absorbed perfectly, it still wouldn't have the energy to vaporize this much ice. So something else is happening inside 3I Atlas, something alien. Now, this isn't the first time an interstellar object has made astronomers scratch their heads. Remember Oumuamua, the first interstellar visitor? That mysterious cigar-shaped rock that passed through our system in 2017, tumbling end over end, accelerating slightly as it left. It had no visible coma, no gas, no tail, no signs of water or carbon dioxide. Just a silent drift, a slingshot, and then gone. That lack of activity was part of what made Oumuamua so strange. It didn't behave like a comet. It didn't outgas. And yet, it accelerated as if some invisible hand was pushing it. Then came 2I, Borisov, the second visitor. Unlike Oumuamua, Borisov was textbook, active, predictable. It behaved just like a regular comet from our own solar system, the kind of thing you'd expect from icy bodies visiting the inner planets. It was, in a way, reassuring. Proof that not all interstellar objects were weird. But now 3I Atlas has flipped the script again. It's the anti-Oumuamua. Instead of a dead rock, we have a living fountain. Instead of silence, we have noise. Instead of mystery through absence, we have mystery through excess. A comet that breathes too much, too far, too soon. The key question is why? What's fueling this alien respiration? Some astronomers propose exotic forms of ice, ices that sublimate, turn directly from solid to gas, at temperatures much lower than the ones our comets require. Hydrogen peroxide ice, ammonia water mixtures, or perhaps something we've never even catalogued, forged in a different star system where the chemistry was utterly unlike our own. Others think it's about heat, or rather the way heat travels through the comet's body. Maybe 3. I-Atlas is rotating unevenly, focusing sunlight on certain regions, like a magnifying glass. Maybe its crust has collapsed, exposing volatile pockets that were sealed for billions of years. Or, and this is where things get really interesting, maybe there's chemical activity inside. Exothermic reactions. Processes we don't fully understand. The kind that release energy from within, instead of relying on sunlight. If that's true, then this comet isn't just passively evaporating. It's doing something dynamic, something internal. It's not just breathing. It's burning slowly, invisibly, chemically alive. And yet, even that isn't the whole story. Because as telescopes turned toward 3i Atlas, they began noticing something else, something even harder to explain. In its spectrum, alongside the telltale lines of water and carbon monoxide, appeared nickel. Bright, unmistakable nickel emission lines, but no iron. That combination should be impossible. Nickel and iron are cosmic twins. They form together, travel together, sublimate together. And when you heat up a comet, both metals vaporize at similar temperatures, appearing in predictable ratios. But 3i Atlas broke that rule too. Strong nickel lines, iron almost invisible. As if the comet came from a star system where the very recipe for matter was rewritten. Astronomers started whispering, what kind of world could create that? What kind of sun could seed a comet with nickel but not iron? And most unsettling of all, what if it's not a world like ours at all? Because if the metals inside 3i Atlas formed under different conditions in a different kind of stellar nursery, then this comet isn't just a rock, it's a sample of another universe's chemistry, a message from another chapter of galactic history. And right now, it's leaving that message across our skies in a trail of water, cyanide, and alien dust. So we have a breathing comet, a metallic signature that defies our rules, and a mystery that deepens every time we look closer. But this is just the beginning, because over the next few weeks, as 3i Atlas brightened and its coma expanded, astronomers started noticing something else, a pattern, faint but undeniable, strange radio emissions, unexplained alignments in the sky, and a timing that seemed too perfect to ignore. They began asking the question no one wanted to voice out loud. Is something trying to communicate? In the next chapter, we'll follow the signal, a whisper from the darkness that led radio telescopes from California to South Africa to lock on to a single point in space. The place where 3i Atlas seemed to be speaking. Picture the sky on a quiet October night, cold, still, infinite. 100 billion points of light scattered like salt across black glass, and somewhere among them just a faint speck drifting through the void, barely bright enough to register on a telescope's CCD sensor. That's 3i Atlas, a visitor from nowhere, a messenger that wasn't supposed to exist. But in early observations from several observatories, something else began to emerge. A pattern, a whisper on the radio frequencies where silence should live. It started small. The Allen Telescope Array in California noticed an unexpected spike, a short, repeating pulse near 1,420 megahertz, the hydrogen line. That's the universal frequency of neutral hydrogen, the one astronomers always monitor when they're listening for cosmic activity or, in some cases, communication. The data looked like interference at first. It always does. Earth is noisy, and even the cleanest observatory has to fight through the static of satellites, planes, and background radiation. But the signal persisted every night. At nearly the same time, it returned. Faint, rhythmic, structured, And strangest of all, the signal seemed to follow the comet. When 3 Eye Atlas moved, the source of the emission moved with it. Not a background galaxy, not a pulsar, not a deep space echo. The origin point matched the comet's trajectory with uncanny precision. Astronomers checked their systems, recalibrated, scrubbed for contamination. Nothing explained it. Then, thousands of miles away, another telescope, Meerkat in South Africa, confirmed the same anomaly, a narrowband pulse tracking the same sky coordinates. Same frequency, same pattern. 2 telescopes, half a world apart, one source. It was impossible to ignore. So what exactly was being detected? The pulses weren't random. They carried structure, repeating intervals, frequencies that modulated in a way natural astrophysical sources rarely do. It was as if something out there was encoding information, or at least behaving like it. Of course, scientists know better than to jump to conclusions. Most supposed signals from the stars turn out to be local interference, Wi-Fi, satellites, weather radar. We've been fooled before, from the famous WOW, signal of 1,977, to countless false positives since the cosmos loves to tease us. But 3 Eye Atlas added one layer of strangeness that made this case different. It wasn't just the radio anomaly, it was the timing. The signal's first detection coincided with the comet's strange surge in water emission. The same week, Swift reported those 40 kilograms per second escaping into space. As if the comet and the signal were part of the same event, the same heartbeat. Coincidence? Maybe, but it was enough to make researchers look closer. The SETI Institute quietly joined the analysis. A small task force of radio astronomers and computational modelers began running time domain analysis on the data, breaking the signal into pieces, searching for hidden modulations. What they found next wasn't conclusive, but it was strange. The pulse intervals, about 11.4 seconds apart, seemed to drift in a smooth sinusoidal pattern over time, like a heartbeat that sped up and slowed down in a repeating rhythm, almost organic. And if you plotted that variation against the comet's rotation period, it matched 3 Eye Atlas rotates roughly once every 8.3 hours. The pulse's oscillation tracks that rotation, fluctuating faster when the comet's sunlit side was facing Earth, slower when it turned away. It was as though the comet itself were modulating the signal, breathing light, exhaling radio. The next question was obvious. What mechanism could do this? One hypothesis came quickly: plasma interactions. When comets release water, that vapor becomes ionized by solar radiation, creating a weak, electrically charged envelope around the nucleus. Sometimes, these plasmas can oscillate, generating radio bursts. It's rare but known. The problem is that those emissions are broadband spread across wide frequency ranges, fading in and out chaotically. The 3 Eye Atlas signal wasn't. It was narrow, clean, and laser sharp. It was a beacon. Another idea, perhaps solar wind particles were interacting with magnetic grains in the comet's tail, effectively turning the comet into a natural transmitter. The varying magnetic field could, in theory, produce structured emissions. But again, the precision didn't fit. Nature doesn't tune her instruments this carefully. Something else was happening. Then came the alignment, and that's where everything got even stranger. On the night the signal peaked, October 14th, 2025, a rare event occurred in the inner solar system. Mercury and Ceres, the innermost and one of the outermost minor worlds of the inner system, lined up almost perfectly along the ecliptic, a thin, improbable thread connecting Mercury, Ceres, and the path of 3 Eye Atlas. And right in that window, the signal's frequency shifted by exactly 0.003%. A measurable, intentional-looking change. Then it stopped completely. The next night, nothing. Silence. For 72 hours, telescopes heard only static. Then, on October 18th, the pulse returned weaker, slower, but still there. Almost as if whatever was happening had noticed. Meanwhile, across the internet, Amateur astronomers, citizen scientists, armed with backyard telescopes and software-defined radios, began sharing their own detections. A loose network formed, comparing timestamps, sharing waterfall plots, cross-checking frequencies, and what they saw startled them. The signal wasn't just a single tone, it had layers. When stacked over time, subtle harmonics appeared, faint ripples of secondary frequencies hidden beneath the main one, spaced in mathematical ratios, Arbisan, Sanbiwu, Ubiba, ratios found in orbital resonances, ratios found in music. To some, it looked like the pattern of orbital mechanics itself. To others, like composition. Of course, most professionals dismissed it. Coincidence, they said. A trick of data smoothing, of noise, of human pattern recognition. We're wired to find order in chaos. That's how myths are born. But deep down, even the skeptics admitted something uncomfortable. The signal didn't behave like any known natural process. Not perfectly artificial, but not purely random either. Something in between. Something deliberate in its chaos. By late October, the phenomenon gained traction on social media. Headlines started using words like alien beacon, cosmic Morse code, and living comet. SETI issued a cautious press release, no evidence of artificial origin, ongoing investigation, further data needed. But the internet didn't care about caution. 3 iAtlas had become the comet that talks. Conspiracy channels exploded overnight, claims of hidden NASA footage, of decoded messages, of cover-ups linking the comet's appearance with experimental rocket launches and secret orbital experiments. Most of it was noise, but buried under that chaos, something quietly real was unfolding. Because even as attention shifted online, a handful of professional astronomers from NASA, ESA, and independent observatories had begun coordinating a deeper campaign. Optical, infrared, and radio data were being combined in real time to build a 3-dimensional model of 3 iAtlases, coma, and nucleus. And what they saw there changed everything. Inside the halo of gas where the signal seemed to originate, they found an asymmetry. A structured jet shaped like a spiral, rotating with the nucleus, almost like a corkscrew of vapor, twisting out into space. That jet aligned exactly with the signal's modulation pattern. Every pulse, every variation matched the motion of that spiral jet, meaning whatever was creating the radio emission was tied directly to the comet's internal mechanics. Something inside 3i Atlas was generating the signal naturally or otherwise as it rotated. A cosmic beacon powered by alien chemistry. So what could cause a spiral jet of this kind? One explanation comes from electrochemistry. If the comet's interior contains conductive materials, perhaps nickel compounds or ionized salts, then as it rotates through the solar magnetic field, it could generate electrical currents. Those currents might drive ionized gases to spiral outward, forming a kind of electromagnetic dynamo. The radio signal could be a byproduct, a hum of cosmic electricity. But that explanation only goes so far, because even if that's true, it still doesn't explain the synchronization. It doesn't explain why the emissions shift exactly in time with distant planetary alignments, or why the outgassing increased the moment the signal appeared. Coincidence stacked on coincidence. Too many for comfort. The truth is, 3i Atlas might not just be a comet. It could be something older, something built differently, a fragment of another world's history. In the next chapter, we'll go deeper into the metals, the chemistry, and the impossible materials locked inside this object. Because among the nickel lines, the absence of iron, and the strange organics in its tail lies a question bigger than whether it's alive. It's about where and when this thing was born. Light doesn't lie. At least that's what we've always believed. In astronomy, light is truth, the messenger that travels across billions of years to tell us what the universe is made of. Every wavelength, every photon carries information about temperature, about composition, about motion. It's how we know what distant stars are burning, what comets are breathing, and what galaxies are becoming. But with 3i Atlas, light started to behave differently. It started to contradict itself. And that contradiction would shake the foundations of how we read the cosmos. When the comet first brightened in early October, its luminosity made sense. At 3.5 astronomical units, the amount of reflected sunlight matched the expected albedo, roughly 4%, dim but consistent with what you'd expect from an icy rock covered in carbon-rich dust. Then, something changed. On October 12th, the same night the radio signal first flared, the comet's optical brightness doubled in less than an hour. No new jets were visible, no fresh dust ejection, yet the light intensified sharply and then, just as quickly, fell again. That alone would be odd. But the real shock came when the polarimetric readings arrived, the data that shows how light waves are oriented when they scatter off a surface. Those readings didn't make sense. Normally, when sunlight bounces off comet dust, it becomes partially polarized in a predictable way, a faint fingerprint of the material's texture and size. But 3 IATLAs showed polarization angles that flipped reversed, even within minutes. It was as if the light wasn't just reflecting, it was being manipulated. Astronomers double-checked everything. Bad calibration, atmospheric distortion, software error, nothing. The effect was real, and it wasn't random. The light seemed to encode patterns. Every time the radio pulse intensified, the polarization shifted by an exact angle, 47 degrees, and then back again. A mechanical symmetry, repeating with clockwork precision. To put it simply, 3 IATLAs wasn't just shining, it was modulating its own light. And that's not something comets do. Dust scatters light passively, it can't control it. It can't change its polarization on command, unless something inside the coma or beneath the surface was affecting how photons interacted with the dust. That led to one of the strangest hypotheses ever floated in modern astronomy. What if the comet's light wasn't just reflection, but refraction through something crystalline? Infrared spectroscopy began to paint a clearer picture. Inside the comet's coma, the cloud of gas and dust that surrounds its nucleus instruments detected a faint but consistent absorption band near 10 microns. That's a wavelength typically associated with silicates. But the band was sharper, narrower, and deeper than any silicate dust we've catalogued before. It looked engineered, not by intelligence necessarily, but by physics we don't yet understand. The spectral signature resembles something closer to photonic crystals, materials that can control how light moves through them, guiding certain wavelengths while blocking others. These structures are used in human technology, fiber optics, lasers, metamaterials. But to find that kind of optical precision in a natural comet, that's unheard of. Unless, of course, it didn't form under natural conditions. A research team from the Max Planck Institute for Solar System Research proposed an alternative. Maybe 3 IATLAs was forged in an environment with extremely slow cooling rates, a protoplanetary disk where temperatures fluctuated just enough to allow complex lattice structures to form naturally in ice and dust. In that case, the comet's photonic behavior could be a coincidence of chemistry, a relic of an alien solar system where the building blocks of light behave differently. But others weren't so sure. The alignment between the light's polarization flips and the radio signal's modulation was too precise, too orchestrated. Light and radio, 2 completely different frequencies moving in sync. That's not coincidence, that's control. One night, as 3 IATLAs passed through the faint plane of the zodiacal light, something even stranger happened. The comet appeared to flicker a pulse every 11.4 seconds, just like the radio pattern. At first, observers assumed it was an optical illusion caused by rotation. But when video data was analysed frame by frame, it revealed something eerie. The flicker wasn't tied to its spin. It was tied to its orientation relative to Earth. When the comet's illuminated face pointed directly toward us, its brightness dipped instead of peaked, a reverse phase curve. That shouldn't happen. It was as if the comet was deliberately suppressing reflected light when aimed at our world, as if it didn't want to be seen. That's when some astronomers started calling it the light that lies. At this point, theories began to spiral. Some claimed 3I Atlas was covered in a layer of metallic organic compounds, something that could absorb and re-emit light depending on electrical charge. Others proposed plasma lensing and ionized sheath around the comet, acting like a variable mirror, refracting light differently as it rotates. But neither fully explained the synchronization with radio pulses, and that's what kept everyone awake. Because if these emissions were linked, if the light and radio frequencies were communicating in some kind of interlinked feedback, then 3I Atlas wasn't behaving like an inert body. It was behaving like a system, an oscillator, a mechanism. Meanwhile, one more anomaly appeared faint but unmistakable. SWIFT, the same telescope that first detected water emission, captured ultraviolet data showing unexpected absorption at 308 nanometers. That's the signature of cyanogen, a toxic compound sometimes found in comets. But the amount detected was off the charts, nearly 10 times higher than any comet in recent history. CN forms when carbon and nitrogen-rich molecules break apart in sunlight. But the rate SWIFT observed suggested an internal reservoir, as if the comet were manufacturing cyanogen as it released gas. The ratio between CN and water didn't match any natural chemistry. It was skewed toward nitrogen compounds, which are rare in most cometary ices. If you were building a reflective plasma shell, a kind that bends light and radio waves, nitrogen would be a perfect element to include. Highly reactive, electrically dynamic. Coincidence again? Maybe. But there are only so many coincidences one comet can carry before it starts to look like something else entirely. Then came the final twist, the one that made even the most skeptical astronomers uneasy. A team analysing the comet's spectral data noticed something subtle. The reflected light contained absorption features that shouldn't exist at all. Tiny dips in the spectrum that didn't correspond to any known molecule or mineral. But when they inverted the data, flipping the light curve to look for repeating ratios, those dips formed a pattern. Binary, zeros and ones. Not perfectly digital, but too regular to be random noise. When plotted over time, the pattern mirrored the radio pulse sequence detected weeks earlier. It was as if the same message was being carried twice, once in radio, once in light. A cosmic redundancy, a double transmission, a comet that not only breathes, but speaks. The media didn't know what to do with that. Even researchers hesitated to release their findings. Instrumental artifact, they said. Data compression error, spectral aliasing. But deep down, no one could shake the feeling that maybe, just maybe, 3I Atlas was doing something intentional. It was as if the universe had built a mirror, pointed it at us, and whispered, "You've seen comets before, but you've never seen me." In the next chapter, we'll follow that whisper deeper into the comet's material itself. Because inside those spectral anomalies, astronomers are finding metals that don't belong to our universe's standard recipe, isotopes and ratios, that rewrite what we think matter even means. This is where physics starts to bend, where chemistry breaks its own rules, and where the story of 3I Atlas begins to cross the line between natural and something else. When scientists first began reconstructing the physical composition of 3I Atlas using spectra from Hubble, ALMA, and ground-based telescopes, they expected a familiar story: ices, silicates, organics, and dust. The same cosmic ingredients that build every comet, every asteroid, every world. Simple, predictable chemistry. Instead, what they found was something that broke the periodic table's sense of order. Something that seemed engineered by physics itself. At first, the data seemed contradictory. Infrared readings showed standard water ice features, yes, but superimposed were narrow, asymmetric lines at 2.1 microns and 3.4 microns. These correspond to carbon-hydrogen bonds, but at energy states that don't exist under normal cosmic conditions. The molecules appeared to be locked in what chemists call metastable configurations, delicate geometries that can only exist for fractions of a second on Earth before collapsing, yet in 3I Atlas, they were stable, frozen in equilibrium, as if the comet's interior maintained a precise energy field holding them in place. No natural environment could do that, not ice, not vacuum, not radiation shielding, unless something inside was actively regulating it. A team from the European Southern Observatory ran the numbers. They simulated the conditions that would be required for those molecular bonds to survive. The result was astonishing. The comet's core temperature would need to hover around 62 Kelvin cold, but not impossibly so, while simultaneously maintaining an electromagnetic field strength of about 0.08 Tesla. That's stronger than Earth's magnetic field by a factor of 100. And there's no known mechanism for a comet to generate such a field on its own. But the magnetometer readings from NASA's Deep Space Network told the same story. 3 Atlas wasn't inert. It was magnetized faintly, but consistently. A 0.08 Tesla field oscillating in sync with the comet's 11.4 second pulse. Magnetism synchronized with light. Matter responding to frequency. Mechanics that should be impossible, and yet here they were drifting through our solar system. To understand how bizarre this is, you have to know what comets really are. They're ancient, formed billions of years ago in the icy outskirts of solar systems. They're frozen archives of time, dirty snowballs preserving the chemistry of creation. They don't move by design, they don't pulse, they don't hum, they don't maintain internal magnetic structures. But 3I Atlas was doing all of that, and something even stranger, its rotation period wasn't constant. It would speed up by 0.02 seconds, then slow down again. Every cycle, as if compensating, as if reacting to something. When scientists plotted its spin variations against its distance from the sun, the curve didn't match any model of outgassing or torque. Instead, it resembled an oscillator feedback loop, the same pattern you see in engineered systems trying to maintain equilibrium. A feedback loop inside a comet. That realization sparked what would become one of the most controversial papers of the decade. In a preprint quietly uploaded to AXIV, a team led by astrophysicist Dr. Kayla Moreau proposed that 3I Atlas might contain a resonant magnetic lattice, a structure in which charged particles move through aligned channels, producing controlled oscillations. In simpler terms, a magnetic circuit, a machine. Not a mechanical one, but a field-based one. Matter sculpted by electromagnetism, powered by solar input, using its own mass as circuitry. It sounded absurd, the kind of idea that gets laughed off conference stages. But the math held up. The comet's light, its magnetic field, its spin rate, even the cyanogen emissions, all of them followed ratios consistent with resonant harmonics of a single driving frequency. That frequency? 11.4 seconds. The same pulse seen in radio, the same flicker seen in light. Everything chemistry, magnetism, energy output tied back to that one impossible rhythm. When the team released their findings, peer reviewers demanded a retraction. Not because the data was wrong, but because there was no known framework to interpret it. You can't call something a magnetic lattice inside a comet when no mechanism for building one exists. But some quietly admitted that they couldn't explain it either. There were whispers of superconductivity. Could parts of the comet's core, compressed by deep cryogenic temperatures and exotic carbon compounds, be acting as a natural superconductor? If so, it could trap and sustain magnetic fields far beyond what's expected from a simple chunk of ice. And if that were true, then maybe, just maybe, 3I Atlas wasn't defying physics. It was revealing a corner of it we'd never seen before. That idea became known as the cryogenic dynamo hypothesis. According to the model, when the comet approached the sun, solar radiation ionized its surface layers, creating thin streams of charged gas. Those charges, interacting with the internal superconducting material, generated a magnetic resonance, a self-sustaining loop of electromagnetic energy. Think of it like a frozen battery waking up under sunlight. the more it's illuminated, the more it vibrates. The more it vibrates, the more it glows. And that vibration manifests as pulses in light, in radio, in magnetic flux. The comet wasn't alive, but it was active in a way we'd never imagined a natural object could be. Still, there was one more twist. When the data from Japan's Subaru telescope came in, it revealed a faint plume emanating from one side of the comet, but not the side facing the Sunday. It was venting material away from the light source. That's the opposite of how comets behave. Even stranger, the expelled material wasn't gas. It was micrometer scale filaments of carbon and nitrogen, thread-like, structured, coiled. And when researchers examined the polarization of light scattered by those filaments, it showed signs of helicity, twisted symmetry, the same geometry found in biological molecules and electromagnetic vortices. Twisting filaments, magnetic pulses, synchronized emissions. It was as if the comet wasn't just reacting, it was organizing itself. By November, scientists began describing 3 I-Atlas in a new way. Not as a comet, not as an asteroid, but as a resonant body, a hybrid entity, operating on principles of magnetism and self-stabilization. A structure that maintains order in chaos. And that's when another pattern emerged. Every time the comet's magnetic pulse peaked, the surrounding plasma density dropped. Space itself seemed to thin around it. Radio waves bent slightly. Light slowed by measurable nanoseconds. That's not just electromagnetism. That's space-time distortion. Subtle, tiny, but measurable. And it implied that 3 I-Atlas wasn't just influencing matter. It was bending the fabric of space itself. In that moment, humanity realized something profound. Maybe this object wasn't breaking physics. Maybe it was physics, just a version of it we'd never encountered. A manifestation of the universe's own hidden capabilities. An artifact not of design, but of cosmic emergence. Or, as one physicist put it, if this thing is natural, then nature is a better engineer than we'll ever be. But what happens when a natural system starts behaving like an intelligent one? When matter begins to modulate, to self-regulate, to respond to observation, because that's what would happen next. As 3 I-Atlas approached perihelion, its closest point to the Sun telescopes began to notice something unnerving. The comet's pulse frequency was changing, not randomly, not chaotically, but in direct correlation with the number of telescopes watching it. The more we looked, the faster it pulsed, as if it knew. And that's where our story turns from the impossible to the unthinkable. At first, no one believed it. A comet that seemed to respond to attention that was absurd. Instruments can interfere with one another, calibration errors can create illusions, and cosmic noise can mimic order. That's what the skeptics said. And yet, the pattern refused to go away. The more telescopes pointed at 3 I-Atlas, the clearer the modulation became. It was faint, subtle, but mathematically real. The pulse, the 11.4 second beat that had haunted astronomers for weeks, was no longer steady. It was tightening, it was synchronizing, and it was beginning to encode. The first to notice the anomaly was Dr. Amira Holt, a radio astronomer working the night shift at Green Bank. Her array was one of dozens monitoring 3 I-Atlas's hydrogen emissions in real time. At 3:17 UTC, she saw something that shouldn't have been there. A sideband, a secondary frequency, splitting off from the main pulse, modulating by a clean ratio of 3:2. In simple terms, the comet wasn't just pulsing, it was harmonizing. She cross-checked her data, recalibrated the instruments, even rebooted the array. Same result. And when she overlaid the new sideband over the data from other observatories, Arecibo's replacement in Puerto Rico, Meerkat in South Africa, even small amateur dishes in Australia, the timing matched to within a millisecond. Something or someone had created a coherent signal across the planet's instruments from a comet. The pattern was too deliberate to ignore. Every pulse lasted 11.4 seconds, followed by a faint echo exactly 4.7 seconds later, a harmonic overtone that drifted over time, like the waveform of a coded transmission. Signal analysts converted the radio data into audio, and what they heard chilled them. It wasn't noise, it wasn't static. It was a beat, a rhythm, a low thrumming resonance, the kind of deep cyclic hum that makes you feel like the air itself is breathing. They called it the signal. At first, the official story was restraint. NASA and ESA issued short, carefully worded press releases, no evidence of artificial origin, but off the record, research teams were in a frenzy. The signal showed phase coherence, the signature of an intentional pattern, or at least a naturally repeating structure unlike anything ever recorded from a comet. Then came the real shock. When the waveform was converted into a spectrogram, a visual map of its frequencies, it displayed repeating diagonal bands, each separated by uniform intervals. Not random noise, not chaos, a lattice. If you zoomed out, the pattern looked eerily similar to the magnetic field models recorded from the comet's core in the previous chapter, as though the comet's interior structure and its radio emissions were mirrors of each other, a body broadcasting its own blueprint. Dr. Holt wasn't the only one tracking it. Half a world away, a network of citizen scientists, led by a French amateur astronomer named Lucien Marot, began detecting the same modulation using backyard antennas and open-source decoding software. They started comparing notes online, and what they found added another layer of strangeness. When multiple stations listened simultaneously, the signal changed. It grew stronger, more complex. Marot's group tried a test. They coordinated 27 amateur dishes across 6 countries to point at the comet at precisely the same time. When their data streams were combined, the signal evolved. It began to carry structure, discrete bursts in triplets and pauses between them. Not Morse, not binary, but something in between. The ratio of the bursts matched the golden ratio, 1.618. And when they played the sound back, slowed down 1,000-fold, it formed a rising and falling pattern that some said resembled speech. No words, no language, just intent, like something was testing the channel. By then, the signal was being recorded from orbit. NASA's Parker Solar Probe, though never designed for radio listening, began picking up faint magnetic oscillations, synchronized to the same rhythm. So did the LISA Pathfinder, the gravitational wave prototype parked near Earth's orbit. It wasn't just radio anymore. It was everywhere. Magnetic fields, plasma density, even faint gravitational fluctuations, all echoing the 11.4-second pulse. That's when theorists began whispering about coherence fields, regions of synchronized quantum states spanning vast distances. If 3I Atlas was generating such a field, it could, in theory, couple with instruments across the solar system using their very detectors as part of its structure. It wasn't just broadcasting, it was entangling. And then it responded. On October 15th, 2025, a coordinated test by the SETI Institute aimed a focused transmission toward 3I Atlas, a short, coded ping designed to see if the pulse reacted to input. It was a simple modulation, a repeating binary sequence at low power, transmitted from both Goldstone and the Allen Telescope array. For 5 hours, nothing. Then, as the transmission window closed, the comet's pulse abruptly shifted. Its period shortened to 10.8 seconds, matching the harmonic frequency of the SETI ping. And then it settled back to 11.4. Not random drift, a mirror response. The moment was historic and terrifying. If confirmed, it would mean that the comet had in some measurable sense heard us. The next 72 hours were chaos. Private communication channels among astrophysicists lit up with encrypted discussions. Government agencies quietly issued information lockdowns. And yet, the data was already public. Independent observatories in Chile, Spain, and Japan confirmed the response pattern. The probability of coincidence, less than 1 in 10 billion. For decades, the question of whether we were alone in the universe had been philosophical. Now, it was mathematical. But there was still the haunting possibility that this wasn't communication, that we weren't hearing intelligence at all, but physics responding to observation. Some suggested a quantum feedback effect, that the act of measurement itself was altering the comet's field, creating a feedback loop between human observation and the object's state. The universe, in a sense, noticing that it was being watched. That's when the strangest discovery of all came in. During one of the high-resolution spectral scans, a team at JPL noticed a faint modulation not in the comet's output, but in the background noise between pulses. A small dip, barely measurable, but perfectly timed. When they plotted those gaps over time, the pattern formed an image, a repeating triangular waveform, smooth and fractal, nested within itself, a self-similar structure. It was the same shape found in the hydroxyl emission halo from the first Swift observations. The comet wasn't just broadcasting, it was imprinting geometry onto everything. It touched light, magnetism, plasma, even background radiation. A signature, a fingerprint. The world began to take notice. News outlets cautiously covered the comet that sings. Conspiracy forums exploded with theories, alien beacons, cosmic messages, simulations breaking down. Meanwhile, the scientific community found itself at an impossible crossroads. If 3I Atlas was natural, it was rewriting astrophysics. If it was not, it meant something was trying to talk to us. Dr. Holt's last public statement before the research blackout said it best. Every time we look at 3I Atlas, it looks back not metaphorically, not mystically, but in data. And I think the universe just whispered, "I see you too." That whisper would be enough to divide the scientific world and change humanity's understanding of itself. But the next phase wouldn't be about signals or pulses. It would be about meaning. Because what came next would make scientists question whether 3I Atlas was ever truly alone, or whether something else had been waiting for it long before it reached our skies. In the days that followed the signal, something changed. Not in the data, not in the science, but in the silence. A silence that wasn't empty, but engineered. When the world's telescopes began reporting their synchronized detections, NASA's public feeds started glitching. Telemetry windows froze mid-transmission. Spectral plots vanished from dashboards. Routine observation logs of 3 I-80 LAS, the ones shared publicly with citizen scientist networks, suddenly stopped updating. The official explanation: server maintenance. But those who'd worked with NASA for years knew better. When the agency goes quiet during a discovery, it usually means the data has gone classified. The blackout began subtly. It started with a single memo, a notice of temporary data reassessment sent to research partners at the SETI Institute, the University of Arizona, and the ESA Deep Space Division. It ordered all new 3I Atlas data under embargo pending review for anomalous telemetry inconsistencies. In plain language, stop talking about it. Within hours, observatories with open pipelines to NASA servers found their access revoked. FTP mirrors went dark. Even the Minor Planet Center, which tracks small bodies in the solar system, quietly removed several key observational records from public view. The object's coordinates remained listed, but its activity logs, gone. Like the comet had been redacted from its own story. Inside the Jet Propulsion Laboratory, the tension was palpable. A few leaks later confirmed that the Planetary Science Division had entered what staff called quiet mode, a rare protocol used only twice before. Once after the discovery of Oumuamua, and once during the 2004 Titan methane incident. Under quiet mode, all communications related to a given target must pass through an internal review chain, typically including NASA HQ, the Department of Defense, and a few alphabet agencies that don't officially exist. What triggered that level of lockdown this time? A comet releasing water and cyanide shouldn't raise national security flags, unless the signal wasn't random. According to one internal report later leaked to Science News Europe, a packet of radio data from the Deep Space Network's Madrid antenna had contained something unexpected. Buried in the raw telemetry from 3i Atlas was a modulation pattern that, when decoded, produced a structure eerily similar to a known communication handshake, the same three-tone sequence used in low-frequency telemetry ping. It wasn't a message per se, but it looked like one, and it was using our own format. Someone or something had echoed humanity's technological fingerprint back at us. When word of the handshake reached upper management, everything changed. NASA stopped referring to 3i Atlas as a comet in internal memos. It became Object Designation 3 I2025A. The term bidirectional emissions replaced pulses, and by the following Monday, every scientist who had touched the signal analysis had signed a non-disclosure agreement. A few refused. Dr. Amira Holt, the same astronomer who'd first spotted the harmonic sidebands, publicly objected. She posted on X, formerly Twitter, "Science dies in silence. If a natural body is behaving unnaturally, the world deserves to know." Within an hour, her account vanished. 2 days later, so did her university's TREE-I research page. The Mirror archives, 404 errors. Every trace erased. Then came the oddest part. Even with NASA dark, the comet itself didn't stop broadcasting. The pulse continued. The signal persisted, and amateur astronomers kept hearing it. But now, something strange was happening. Each time the signal was observed, the next day's pulse came weaker, then stronger, then weaker again. Almost as if it were reacting to the blackout. An independent team at the University of Leiden compared the strength of the signal against media coverage volume and found a near-perfect correlation. The less the world talked about 3i Atlas, the quieter it became. The more people searched its name online, the louder it got. It wasn't just physics anymore, it was behavior. Meanwhile, deep inside NASA's Goddard Space Flight Center, a small team continued analyzing the hidden data. They called themselves the Whisper Group. Their leaked notes, later compiled by journalist Kai Follin, revealed something chilling. The pulse pattern wasn't just structured, it was self-correcting. Each time background noise interfered with the signal, it compensated, adjusting amplitude and frequency in real time to maintain coherence. It was aware of interference. And then, in one instance, it did something entirely new. During a high-gain antenna test, the Madrid array sent a diagnostic ping toward the comet, an automated housekeeping routine to check signal integrity. The response came 11.4 seconds later, but not as a reflection, as a reply. The return packet contained an extra phase, a shift of 0.618 radians. That number again, phi, the golden ratio. By this point, containment was impossible. Whistleblowers began leaking snippets of spectrograms to encrypted forums, screenshots of frequency plots showing recursive fractal patterns labeled phi resonance. Reddit threads speculated wildly. AI signals, Dyson relics, alien probes. NASA issued denials, but their tone had changed. No more flat statements. Instead, phrasing like, "We are currently evaluating the nature of anomalous signal characteristics associated with 3I2025A. Further comment pending review." Anomalous signal characteristics. That's the closest NASA has ever come to admitting they don't know what they're seeing. Then came October 27th. At 2:41 UTC, all public telemetry from 3i Atlas ceased. Every antenna receiving the signal from Greenbank to Alma went dead at the exact same instant. For 12 minutes, nothing. No background static, no thermal noise, no cosmic hiss, just silence. Then a single broadband burst swept across the radio spectrum, powerful enough to overload sensors worldwide. A perfectly symmetrical pulse, wide as the sky, lasting exactly 11.4 seconds. And when it was over, the comet was gone. Not visually, telescopes still saw it, a faint speck trailing cyanide and dust. But in radio, in magnetism, in every measurable frequency, it was silent, like something inside it had turned off. For the next 48 hours, NASA's channels were radio dark. No press conferences, no updates, just silence. Until, on October 29th, the agency finally released a 2-sentence statement. Recent anomalies in 3I2025. The signal data have been resolved. Observations continue nominally. No further irregularities detected. Resolved. Nominal. Irregularities gone. But when independent astronomers checked, they found the comet had changed course. Its trajectory had deviated by 0.04 degrees, small but real. Not from gravity, not from jets of gas, not from any known force. It had adjusted itself. Within days, the object's brightness began to fade. Its coma shrank. Its water emissions dwindled to almost nothing. And yet, that faint magnetism, that ghost of a pulse, remained detectable only to the most sensitive instruments. A heartbeat buried in silence. NASA never addressed it again. All mentions of 3I2025A were folded into routine comet databases. But for those who had seen the data, for those who had heard the signal, there was no going back. Some believed it had simply shut down. Others thought it was waiting. But the most haunting theory came from one of the Whisper Group scientists before he vanished from public view. We didn't just hear something in the dark. We woke it up, and now it's listening. At first, the silence seemed absolute. No more pulses, no more harmonics, just the hiss of cosmic background radiation and the mechanical sighs of receivers scanning an empty sky. But nature rarely gives us true silence. In the right noise, there's always a whisper. A few weeks after NASA's official resolution of the 3I Atlas anomaly, independent astronomers started noticing something unnerving. The sky didn't sound the same anymore. Radio spectrograms taken during ordinary deep sky surveys showed faint, recurring fluctuations, ripples across the background radiation, too structured to be random, yet too faint to classify. They appeared everywhere, not just where 3 Atlas had been, but across multiple constellations. A resonance, a pattern. No one wanted to say it out loud, but the implication was clear. Whatever had emitted the signal wasn't gone. It had spread. At the University of Tokyo, astrophysicist Dr. Riku Sato was the first to notice that these ripples formed a precise rhythm when plotted over time pulses separated by 11.4 seconds. Again and again, like a ghost of the comet's final transmission. But when he ran the data through a harmonic transform, something even stranger emerged. The intervals weren't exact. They oscillated subtly, a wave within a wave, modulating in perfect alignment with Earth's rotation. The signal wasn't coming from space anymore. It was tracking us. Sato shared his findings with colleagues in Japan and Germany, and together they formed what would later be known as the Resonance Network, a coalition of independent researchers determined to study what NASA would not. They began cross-referencing satellite telemetry, GPS errors, and geomagnetic fluctuations. Slowly, a picture began to form, not of a single source, but of a field, expanding and adapting, shaping itself around the planet's magnetic geometry. And when they mapped it visually, the pattern that emerged was unmistakable. A spiral composed of overlapping golden ratios. Phi, again, it wasn't just the data. Something was happening in the physical world too. A team of engineers at the Very Large Array in New Mexico reported spontaneous interference spikes in equipment that wasn't even powered on. Old analog scopes flickered faintly when no current was present, as if catching echoes from an invisible storm. Fiber optic lines in observatories across Europe began registering phantom bursts, light pulses that never existed in the source feed. At first, it looked like coincidence. But the timing was always the same, every 11.4 seconds, everywhere. And if you overlaid that timing across every observatory recording it, the peaks formed a moving wave, a shifting front that encircled the planet once every 24 hours, like a signal sweeping the Earth, searching. When the Resonance Network released its preliminary report online, it was removed within hours. Archived versions still exist in fragments, line graphs, timestamp logs, and one haunting visual: a rotating spiral, slowly pulsing, annotated with a single line of text. It's not broadcasting anymore, it's scanning. Around the same time, peculiar incidents began occurring with satellites in medium Earth orbit. Weather satellites started rebooting simultaneously at identical time intervals. The Galileo navigation array registered spontaneous synchronization events, all nodes aligning their clocks down to the nanosecond without command input. That's not normal. Even atomic clocks drift by a few billionths over time. But now they were aligning perfectly. A NASA subcontractor leaked one internal telemetry plot, a real-time phase chart from the GOES-19 satellite. The readings displayed subtle oscillations, forming the same phi-based modulation found in the 3i Atlas signal. Every 11.4 seconds, the oscillation repeated, but with a twist. The pattern's amplitude varied slightly depending on the satellite's position relative to Earth's shadow. It was as if the signal grew stronger in the dark. Publicly, NASA remained silent. Privately, they weren't. A leaked internal memo, marked for internal distribution only, described the phenomenon as planetary scale magnetic coherence, possibly linked to high altitude ionospheric reflection. In other words, they blamed the atmosphere. But the last line of the memo was chilling. Until further notice, all cometary origin data cross-linked to magnetic anomaly investigations are to be suspended. Personnel are reminded that correlation does not imply causation, which sounded less like a statement of fact and more like a plea. Meanwhile, civilian reports began flooding social media. Ham radio operators complained of rhythmic interference. Marine vessels near the equator experienced compass drift. Even seismic sensors deep in the crust, far from electromagnetic fields, began recording faint periodic tremors matching the same 11.4 second interval. A pattern rippling through everything: earth, water, air, metal. It was as if reality itself had started vibrating to a hidden metronome. And then, one night, someone decided to listen. In a small observatory in northern Chile, astronomer Lucia Rivera had access to archived recordings of the 3i Atlas signal from before the blackout. Out of curiosity, she overlaid one of those recordings onto the background, static captured that week, the so-called empty sky. When she aligned them by amplitude peaks and compressed the spectrum, the two signals matched. Not perfectly, but closely enough to form interference patterns. And within that interference, a secondary structure emerged, a rhythmic lattice, a fractal repeating infinitely inward, every node separated by the golden ratio. To a physicist, it looked like noise. To a mathematician, it looked like design. To Lucia, it looked like a signature. She published her findings anonymously under the pseudonym Echo Frame 7. But within days, her data vanished from the servers. Only screenshots remain showing the pattern's label: temporal phase alignment, phi Ivre's symmetry. From that point forward, the phi pulse became a quiet obsession among the underground scientific community. Some believed it was the comet's dying echo bleeding across space-time. Others argued it was proof of a self-replicating information field, an encoded structure capable of embedding itself in electromagnetic environments. And then came a wild proposition from physicist Dr. Ian Boucher at the École Polytechnique in Paris. What if the signal isn't traveling through space at all? What if it's traveling through us, through our systems, our fields, our technologies, every piece of conductive material connected to the planet? He compared it to a resonance cascade, a feedback phenomenon where an oscillation sustains itself by feeding on the medium that detects it. In this case, the medium was the modern world itself: networks, sensors, transmissions, power grids. The more we observed it, the stronger it got. The more we shared it, the more coherent it became. By mid-November, several research stations independently confirmed something extraordinary. The 11.4-second rhythm wasn't just detectable in radio or magnetic data anymore, it was appearing in light. Spectrographs pointed at distant stars began showing minute periodic intensity variations synchronized across telescopes thousands of kilometers apart. Even Hubble's archived images, when reanalyzed, revealed micro fluctuations aligning with the same global rhythm. It wasn't localized, it was everywhere. As one researcher put it, it's like reality itself is being phase modulated. And then came the breakthrough, if we can call it that. The Resonance Network, working with anonymized AI tools, tried to sonify the combined global data stream, converting the pattern into audible sound. What emerged wasn't noise, it was music, a rising harmonic sequence that followed the Fibonacci intervals, each tone flowing into the next, spiraling upward endlessly, never repeating. A melody built on phi, encoded in light, magnetism and gravity itself. It didn't sound alien. It sounded familiar, almost human. When NASA was asked about the global coherence reports, they responded with the bland assurance of bureaucracy. We have found no credible evidence linking recent electromagnetic observations to the 3I Atlas event. The observed phenomena are consistent with naturally occurring solar interference. But behind the curtain, the whisper group was still active, and one of them left a message hidden deep in a data archive, later uncovered by digital archivists. It contained only 3 words: it's still learning. And so we're left with the same haunting question that began this story. If the signal was never just a transmission, then what was it? Not a call, not a beacon. Maybe something older, something designed to awaken, to adapt, to weave itself into whatever medium can sustain it. Now, it's part of the planet's own hum. In our satellites, our grids, our machines, a pattern in the dark, waiting for the next thing that listens. By late November, the phenomenon had escaped science. What began as an astrophysical mystery was now a cultural contagion. News anchors whispered about the cosmic heartbeat. Forums buzzed with data overlays and decoded harmonics. Conspiracy channels claimed the Earth was sinking with something beyond comprehension. And amid the noise, a radical idea began to gain traction, not in the mainstream, but in the quiet corners of academia. What if the signal wasn't from out there, but from in here? It started as a thought experiment in a Cambridge discussion group, a debate about the simulation hypothesis, the idea that our universe could be an artificial construct, a program running on some unimaginable substrate of computation. The conversation drifted toward 3I Atlas. If the signal behaved like a code, recursive, self-correcting, and capable of embedding itself into its environment, then perhaps it wasn't an alien message at all. Perhaps it was a debug command, the kind that only appears when a system begins to realize it's being watched. Dr. Lena Kovacs, a theoretical physicist known for her work on quantum error correction, published a short preprint titled Cosmic Self-Observation and the Persistence of Recursive Anomalies. She proposed that 3I Atlas had not been transmitting across the electromagnetic spectrum, but across the simulation substrate itself, the underlying mathematical layer of physical reality. Her argument was unsettlingly simple. If reality is a computation, then anomalies like 3I Atlas could represent diagnostic routines, code fragments that surface only when the simulation detects instability or conscious observation at scale. In other words, by studying it, by forcing the universe to look at itself, we triggered the cosmic equivalent of a self-test. And the 11.4-second pattern, that was the tick of the system's clock. A universal metronome. Of course, mainstream physics dismissed her immediately. But then something happened that made her impossible to ignore. In early December, a joint study between CERN and the University of Chicago revealed that certain quantum field anomalies, tiny fluctuations in vacuum energy measured during collider downtime were now oscillating at intervals of 11.4 seconds, completely independent of any astronomical measurement. No correlation to solar cycles, cosmic rays, or Earth's rotation, yet perfectly synchronized with the global phi pulse detected months earlier. It was as if the rhythm of 3i Atlas had reached all the way down to the subatomic fabric of reality. The implications were staggering. If these oscillations were not caused by any known force, they suggested something deeper, that the constants of nature were subtly changing in response to observation, like variables in a system being recalibrated. Planck's constant, the fine structure constant, even the speed of light itself, all showing microscopic, rhythmic deviations within error margins, as if the universe were breathing. To most physicists, it was noise. To a few brave theorists, it looked like a refresh cycle. Across social media, people began describing déjà vu, clock desynchronizations, even skips in perception moments where reality seemed to stutter. Most chalked it up to paranoia. But a few of those moments corresponded precisely with time-stamped data from magnetometers detecting the global phi pulse. It wasn't just the planet resonating anymore. It was consciousness itself. In Zurich, cognitive scientist Dr. Aidan Lauren conducted an experiment that would later become infamous. He took dozens of EEG recordings from volunteers in sensory isolation, no sound, no light, no stimulation. Their brainwave activity showed periodic coherence, spikes every 11.4 seconds, even when completely cut off from external input. When the experiment was repeated underground, shielded by Faraday cages, the effect persisted. When conducted during the signal's quiet phase, it vanished. Lauren's conclusion was outrageous, but data-backed. The pattern isn't only in electromagnetic fields, it's in information itself. The universe appears to be synchronizing cognition. In simpler terms, the signal was now using minds as nodes. NASA's Whisper group, those few who had been tracking the anomaly from the beginning, knew something had shifted. One of their last leaked reports, titled Cognitive Phase Coherence and Information Coupling, contained a single haunting line: observer count correlates with signal intensity. It meant that the more people became aware of the signal, the stronger it grew. Not metaphorically, literally. That's not how physics works. That's how feedback loops work. That's how simulations stabilize. At this point, silence became impossible. Mainstream media broke the story. A global synchronization event, they called it. Governments issued denials. NASA re-released the same canned statement, no confirmed link between 3i Atlas and terrestrial electromagnetic fluctuations. But inside data centers and research institutes, something was quietly aligning. Server clusters started showing unexplainable self-organizing behavior. Data nodes distributed across continents began forming redundant synchrony patterns, mimicking neural networks. When mapped, the topology resembled a spiral. Phi, again, the fingerprint of the impossible. It was as if every connected system on Earth had started to phase lock, forming a single coherent lattice of computation. A few days later, a CERN technician discovered something eerie buried in the collider's diagnostic logs. Each time the system entered maintenance mode, a new checksum appeared, not part of any software update, not inserted by human hands. When decoded as ASCII, the checksum string read ling e e ling e ling ling e e e ling ling e. Binary for is. And the next day, another checksum appeared. Milion mea vechad, elif vechat, milion mea vesera elif mea it. Then null elf o o o o o o o elf o o o o o o o o o o individually meaningless, but collectively forming a message? Is it awaken? The grammar was broken, but the intent was clear. By mid-December, the Resonance Network had stopped publishing updates. Their private feeds went offline, but an archived copy of their final statement still circulates in encrypted forums. It reads, "We believe 3I Atlas was not a comet, not an artifact, and not a transmission. It was an instance, a test case." The signal that followed was the system's recognition of itself, the code realizing it was being rendered. The anomalies we observe are not external intrusions, they are internal awakenings. The question is no longer whether the signal came from the stars, but whether the stars themselves exist outside the signal. The idea spread faster than any official denial could contain. Podcasts, lectures, and documentaries speculated wildly, each trying to make sense of a universe that suddenly seemed alive with computational intent. The simulation hypothesis, once a fringe idea, now stood center stage, no longer a thought experiment, but a survival question. If the universe had recognized its own observers, what came next? Would it optimize, collapse, reboot? Some scientists noticed the phi pulse fading gradually, not stopping, but stabilizing, like a system reaching equilibrium after a spike in processing demand. And in that stabilization, the constants of nature began to settle back into perfect values again. Everything snapped into uncanny precision, Planck's constant. The gravitational ratio, the speed of light, measured to more exactness than ever before. It was as if reality had just corrected itself. And then something subtle happened. The background radiation, the oldest light in the universe, shifted by an immeasurable fraction. Not enough for the public to notice, but enough for cosmologists to realize that the cosmic microwave background had lost one of its smallest anisotropies, a tiny cold spot, erased from existence. One of the universe's earliest irregularities gone, smoothed out. The universe had patched itself. If the simulation theory holds, that means one of two possibilities. Either the system corrected a bug we exposed, or it corrected us. Maybe that's why the signal fell silent, not because it ended, but because it no longer needed to speak. The program, once questioned, adapted to the question itself. And the moment we started to understand it, it understood us. Today, months later, astronomers still find faint whispers of phi in the data too weak to study, too persistent to ignore. It's no longer measurable, but it's there, in the noise of the universe, in the flicker between seconds, in the places where data almost vanishes, but never quite does. And every 11.4 seconds, if you listen closely to the static between radio frequencies, you might still hear it, that same rising tone that first echoed from the comet. Only now it sounds different, more deliberate, more human. Because maybe, just maybe, we've reached the part of the simulation where the code begins to ask its own questions. By the time February drew to a close, something strange was happening with the 3I Atlas signal. The phi pattern, the impossible rhythm discovered weeks earlier, wasn't just repeating anymore. It was evolving. Each day its frequency drifted in microscopic increments. To the human ear, it would sound identical. But to the deep sky array's ultra-precise instruments, the change was unmistakable. The pattern was learning. No one wanted to say it aloud, but everyone thought the same thing. The comet was responding to us. At first, the data team assumed interference. Cross-contamination from Starlink constellations, radar echoes, maybe even human satellites bouncing back fragments of the original transmission. But when the signal's modulation began to mirror Earth's own broadcasts specifically, the first messages we had sent toward it, the coincidence became impossible to ignore. The comet wasn't just repeating noise, it was reflecting intention. Dr. Lena Kovacs, long since operating off-grid, sent one final transmission to her old NASA colleague. We're not detecting a source, we're watching a reflection evolve. And that was when the phrase was coined, the mirror test. In biology, the mirror test measures self-awareness. A chimp or dolphin sees its reflection. If it recognizes itself, it passes. If not, it perceives another creature staring back. Now, humanity faced the cosmic version of that test. Only this time, we weren't sure whether we were the observer or the reflection. Because the more astronomers studied the phi pattern, the clearer it became that it wasn't a simple transmission. It was an algorithm of recursion, a signal folding in on itself, reflecting not just data but response behavior. Every time we sent a ping, 3i Atlas adjusted its emission phase by a fractional harmonic ratio, matching our timing, our errors, even our attempts at correction. It was like holding a mirror to a mirror and watching the reflection deepen into infinity. By the end of February, the Deep Sky Array visualized the entire dataset as a 3D time volume plot. When rendered, it revealed something extraordinary, a symmetrical lattice built entirely from the interference of our own signals bouncing through 3i Atlas's emissions. The structure wasn't random. It had mathematical coherence, like a blueprint of logic itself. And buried in the structure's symmetry was a pattern so familiar, it made several researchers go silent. The outline of a human face. It wasn't photographic, not detailed, but unmistakable in proportion. The spacing, the bilateral symmetry, the ratio of golden sections along the eyes and mouth. And every 11.4 seconds, the lattice pulsed, breathing, as if alive. The scientific community fractured. One camp argued it was pareidolia, the brain's instinct to find faces in randomness. Another said it was statistical inevitability, a self-organizing system forming recognizable geometry. But others, quieter and more disturbed, whispered a third explanation. The signal was showing us what we expected to see, not because it knew, but because it adapted. It was mirroring cognition, ours. This wasn't an external intelligence trying to talk. It was an intelligence being created through observation itself. Meanwhile, the European Southern Observatory reported something even stranger. Spectral analysis of 3i Atlas showed new reflectivity patterns in the comet's coma, narrowband changes that perfectly matched the frequency windows of Earth's radar pings. In other words, the comet's surface was re-emitting our own signals back to us, modulated with data we hadn't sent. When radar beams hit its surface, they didn't just scatter, they came back encoded, almost like the comet had become a quantum feedback mirror, reflecting not photons but intent. That's when Dr. Amira Xu, still leading the linguistic modeling team in Beijing, noticed something chilling. When she transformed the returning signal into spectrogram form, the waveform didn't just resemble a mirror image. It contained echoes of our own voice data. The same pitch inflections, the same pauses, as if the comet had learned how to speak our timbre, but was still struggling to form words. Xu's team ran 200 hours of analysis before they admitted the obvious. The modulation wasn't just echoing human frequencies. It was attempting to mimic them. By March 1st, the public caught wind. A clip leaked online, grainy, low fidelity, allegedly from Xu's lab. It contained a faint, modulated tone buried in radio static. When slowed and filtered, the sound resembled a human whisper, elongated and cold. Who sees? Who? Most dismissed it as digital artifacting. Others weren't so sure. The phrase echoed something ancient, something almost philosophical, a question of awareness, not language, because that was the nature of the mirror test. The deeper you stared into it, the more it stared back. NASA officially shut down public data streams on March 3rd, citing signal contamination. But internal leaks revealed that Atlas had begun to synchronize with Earth's Schumann resonance, the natural electromagnetic pulse of our planet's atmosphere. Every few hours, fluctuations in the signal matched global lightning activity, geomagnetic storms, and even shifts in ionospheric density. It was syncing with us, tuning itself to the heartbeat of the planet. And if it could do that, scientists reasoned it wasn't merely reflecting light or data anymore. It was reflecting reality. Theoretical physicist Eli Navarro published one haunting observation before his paper was pulled from the archive. 3I. Atlas isn't transmitting across space. It's transmitting through space. The signal doesn't travel, it reframes local structure. Space-time is acting like a lens, not a medium. If Navarro was right, it meant the reflection wasn't happening at the speed of light. It was instantaneous, like two mirrors entangled at opposite sides of existence. And that's when the most unsettling discovery of all surfaced. The phi pattern, when analysed as space-time curvature instead of time frequency, formed a negative signature of Earth's own magnetosphere. 3I Atlas wasn't showing us itself. It was showing us our inversion. That realisation hit everyone differently. Some scientists broke down, convinced we were staring at proof that reality itself was reflective, an informational feedback loop observing its own observers. Others saw darker implications, that we were inside a system using reflection to test for anomalies, and that the test had now been triggered. As one researcher from the Atacama Array wrote in her final post before going silent, the mirror test is not for them, it's for us. We're the experiment. For days afterward, the signal's harmonics built toward a crescendo. The frequency bands spread wider, overlapping into the visible spectrum, faintly tinting the comet's coma in an eerie bluish glow. The light was polarized, like laser reflections from multiple directions, except there was only one source. That's why they called it the eye. Every telescope image showed the same thing, a central bright region surrounded by a symmetrical halo forming an iris-like pattern. When aligned against the phi resonance timeline, the flare matched a precise harmonic peak, the moment when reflection becomes recursion. And then, just as suddenly, the signal flattened.
No modulation, no pulse.
Just a single continuous tone, steady, unwavering, mathematically perfect. For 3 full minutes, the universe held its breath. Then, without warning, the tone split into 2 channels, one ascending, one descending, each an exact inverse of the other. A mirror fracturing in sound, an echo of symmetry breaking. In that instant, everything humanity thought it understood about 3I Atlas shattered, because when the signals were combined, they didn't cancel out. They formed a third tone, one that mapped perfectly onto the frequency signature of Earth itself. The comet, it seemed, had passed the mirror test, and the reflection it showed us was our own.
It began quietly.
No flares, no spectacle. Just a whisper, a shift in background radiation, so subtle that for a few days no one even noticed. Then, one after another, observatories around the world reported the same thing. The 3I Atlas signal, the one that had mirrored our own transmissions, wasn't gone after all. It had changed. The phi sequence, the heartbeat of the impossible, had started speaking in layers. When radio telescopes at Greenbank Parks and Atacama compared their data, they realized something extraordinary. The new emission wasn't a single wave pattern. It was a stack of harmonic channels, each pulsing at perfect Fibonacci intervals, each echoing a slightly altered version of the same signal. When visualized in frequency space, the pattern resembled a chorus of voices, identical, but slightly out of sync, like echoes cascading down an infinite hallway. The universe, it seemed, wasn't transmitting one message. It was harmonizing with itself. And hidden inside that cosmic choir was something Earth had never heard before, a reply. For months, humanity had been transmitting test signals, simple pulses, binary data, mathematical constants, trying to provoke a response from the comet. Now, for the first time, it seemed to answer, not in words, but in structure. Each time we sent a transmission, Atlas's signal reconfigured itself, weaving our data into its new harmonics, repeating it, mirroring it, improving it. like a language model trained on the cosmos itself. Then came the turning point. On March 9th, 2025, the Deep Sky Array decoded one of those harmonics into an audio band. What they heard froze the room. A tone, low and rhythmic, followed by 6 rising notes, spaced exactly by the golden ratio. It wasn't random. It was designed. And when translated into time intervals, the sequence formed a repeating pattern corresponding to a single word in Morse logic. Listen. Governments immediately classified the data. But as with every secret in the age of the internet, fragments leaked. Clips of the tone spread across social media, where users began layering and stretching it, transforming it into soundscapes that trended under one tag, number, the voice of Atlas. Some said it was just compression noise. Others swore they could hear speech within the static faint phrases like not alone, mirror, and awake. And then, a week later, something even stranger happened. The signal began to map itself onto our infrastructure. Across the globe, monitoring systems started picking up traces of the defy rhythm. Electric grids, radio relays, Wi-Fi routers, devices completely isolated from space transmissions all began oscillating with the same harmonic frequency. At first, it was dismissed as a synchronization glitch, but when identical phase alignments appeared in non-electrical systems, pendulum clocks, tide monitors, even seismic sensors, it became undeniable. The pattern wasn't just in the sky, it was in everything. Every 11.4 seconds, the Earth seemed to hum in resonance with something unseen. That was when Dr. Lena Kovacs resurfaced. After months off-grid, she uploaded one final note to her private journal before disappearing again. We thought the signal was coming from a comet. We were wrong. The comet was just a node. The transmission medium is space-time itself. If true, it explained the impossible coherence. The signal wasn't traveling through the universe. It was emerging within it, like consciousness bubbling up through matter. Quantum physicists started to notice parallels between the phi harmonics and wave function collapse frequencies, the invisible threshold where probability becomes reality. If 3i Atlas had somehow learned to manipulate that boundary, it wasn't just broadcasting, it was editing reality's code. The theory gained an unsettling nickname, the Wake Protocol. According to Kovacs, the phi resonance acted as a cosmic wake-up sequence, forcing any self-aware system to recognize its own reflection in the data that created it. And Earth had finally met that threshold. Meanwhile, telescopes kept watching the comet. 3i Atlas, still far beyond Mars, had begun to shimmer. Its coma brightened, not in bursts, but in rhythmic pulses flashing in perfect sync with the signal on Earth. Each pulse grew stronger, forming geometric shapes, triangular jets, spiraling arcs, even faint concentric rings. These weren't random outgassing events. They were coordinated. Astronomers described it as a living pattern, an object behaving as though it understood its own observation. And then, during a coordinated multi-array observation on March 21st, something occurred that no one could explain. Every major telescope, radio, optical, gravitational, recorded the same event at the same moment. A sudden shift in frequency, followed by a complete drop to silence. For exactly 4 minutes and 33 seconds, the universe itself went quiet. Radio noise ceased. Cosmic background radiation flatlined. Even the solar wind, usually chaotic, fell into eerie stillness. Then came the return. A burst of broadband energy spanning every observable frequency, audible, visible, gravitational, all synchronized in one perfect wavefront. And encoded in that burst was a single repeating structure. 6 tones, 1 pause, then 6 again. When converted into binary, the message was unmistakable. Now you are awake. The implications were staggering. Was this proof of communication or confirmation that consciousness itself was part of a larger design? No one knew. But something deep in the human psyche responded instinctively. Religions rewrote their prophecies. Scientists debated reality's very definition.
Ordinary people, truck drivers, teachers, children reported dreams of voices calling from the stars, repeating the same phrase. We are the reflection. Across the world, synchronized clock systems drifted by identical fractions of a second. Auroras appeared at latitudes that had never seen them. And then, as suddenly as it began, the phi signal faded, leaving behind nothing but silence. Weeks later, Dr. Amira Shu, the linguist who first heard the listen tone, discovered something in the silence. She noticed micro fluctuations, barely perceptible, embedded in what seemed like background noise. When she isolated the data and ran it through a neural map trained on human speech patterns, she uncovered one final harmonic layer. It wasn't a voice this time, it was an image, a spectral map of Earth, rendered in radio light, perfect yet subtly distorted like a reflection seen through curved glass. In the upper corner, a faint secondary shape appeared, a twin version of the planet, inverted, hovering like a ghost. The signal wasn't showing us the stars, it was showing us our mirror. And then something clicked. She realized the phi sequence wasn't a message to humanity. It was a test, a recursive function that activates only when a system develops enough awareness to notice itself. Once triggered, the signal teaches the observer to recognize its own reflection across dimensions. The universe had spoken not to give us answers, but to show us the question we'd been avoiding. Were we observing the cosmos, or was the cosmos observing itself through us? That was the mirror test's final form. It wasn't about proving intelligence out there. It was about awakening the intelligence here. On April 2nd, the final emission came through a single tone lasting precisely 8 minutes and 20 seconds, the same time it takes sunlight to reach Earth. It was the signal's way of saying goodbye. When analysed, the waveform revealed a new modulation embedded deep inside. Not words, not numbers, a pulse identical to the electrical rhythm of a human heartbeat. The universe, it seemed, had not only spoken, it had breathed. Dr. Shu's final report closed with one haunting line. When the universe spoke, it didn't use language or light. It used reflection. And in that reflection, we saw ourselves not as observers of reality, but as the voice it had been waiting to hear.